All right, this is Algebra 2, Target 38. Welcome back. This is part 2 of Target 38. I can use trigonometry to solve right triangles. Today we're going to be taking a look at how to use trigonometry, our 6 trig ratios, sine, cosine, tangent, cosecant, secant, and cotangent, to find missing sides of a triangle. So, to start with, when we find all unknown side lengths and angle measures of a triangle, this is called solving a triangle. Okay, and that's really kind of the objective here of this target, is to be able to solve a triangle. Today we're going to look at finding the unknown side lengths. Now, in part 1 we looked at trig ratios that for angles of 30, 45, and 60, okay, as trig ratios that we should just know. And hopefully you've been starting to work on memorizing those. But other angle measures we can use the calculator for. Okay, and if you take a look at most calculators will have buttons, okay, that say sine, cosine, and tangent. Okay, so if we look at our calculator here, here's sine, cosine, and tangent. Okay, and most calculators will have those. All right. So, one thing that we do want to make sure, though, is when we use the sine, cosine, and tangent keys, as well as the reciprocal key, okay, the reciprocal key for secant, cosecant, and cotangent. And what they mean by the reciprocal key is, again, if we go back and look at the calculator, there is a button right next to sine, cosine, and tangent that says x to the negative 1. Okay, that is what we call the reciprocal key. So if you do sine of 30 degrees and then press x to the negative 1, okay, that will give you the cosecant of 30 degrees. All right, one thing that we want to make sure, though, anytime we're working with angle measures in degrees, okay, we want to make sure that if we go to the mode, that we are set in degree mode. So you can see right now, if you go down to the third line of the of my mode, you can see that I'm in radian mode right now. Okay, I want to be in degree mode. If we're working with degrees, okay, if we have our angle measures in radians, which is what we saw in target 37, then we would use radian mode. So depending on how your angle is given, which typically in math we use degrees, but if you're working in science applications or other types of applications, oftentimes you'll use radians. So you may want to make sure that you're in the correct mode based on what types of angle measures you're using. All right. So let's start with an example. Okay, if we want to find the value of x for the right triangle shown. In order to do this, we want to look at the angle that we know, which is 30 degrees right here. And then based on that, we want to look at what sides we know and what side we're looking at, trying to find. So we have the longest side here, that's the hypotenuse. And then the side that we're looking for is the other side that helps create the angle. So we know that that is the adjacent. So now the two trig ratios that use adjacent and hypotenuse would be the cosine. Right? So the cosine of theta we know is defined as the adjacent over the hypotenuse. And then its reciprocal would be the secant, which is the hypotenuse over the adjacent. All right, so what we want to do is we always want to use the trig ratio that has the known side. Right? So this time we know the hypotenuse. The known side is in the denominator. Okay, had we known the adjacent and we're looking for the hypotenuse, then we would want to use the secant. But you always want to use the trig ratio that uses the two sides that you're working with, and the side that you know is in the denominator, because that's going to be the easiest to solve. So we'll use cosine. So if I set up my equation, it'll be cosine of 30 degrees, okay, equal to the adjacent, which is x, okay, divided by the hypotenuse, which is 8. Now, the cosine of 30 degrees, okay, we know from our table back here, is the square root of 3 over 2. Right here's 30 degrees, cosine square root of 3 over 2. All right, so we can fill in cosine of 30 with the square root of 3 over 2, okay, equaling x over 8. And then to solve for x, you just multiply both sides by 8. So we end up with 4 times the square root of 3 equals x. And then if we want to get a decimal approximation, go to our calculator and do 4 times the square root of 3. And that would equal about 6.9. Okay, so we have x is approximately 6.9. And that's how we find the missing side. All right, so always look at what side you know, what side you're looking for. Okay, use that to figure out which of the two trig ratios would apply, and then use the one that has the known side in the denominator, and then set it up as an equation, and then go ahead and solve. All right, so here we want to solve triangle ABC. So we want to find the missing sides and missing angles. So since we know that this angle is 28 degrees, okay, this angle and this angle up here have to add up to 90 since we have a right angle over here. So 90 minus 28 would give us 62 degrees for this missing angle. And then to find the missing sides, we're going to want to use our trig ratios. So we have the angle here. Okay, we know, well, let's first identify the hypotenuse. So that's here. And then the adjacent side would be the other side that creates that angle. So this is the adjacent side, which leaves A as the opposite side. All right, so if we want to find A, that's the opposite side, and we know the adjacent side. So the two trig ratios that we could use would be tangent of theta equaling opposite over adjacent, or cotangent of theta equaling adjacent over opposite. But since we know the adjacent side, let's use the tangent. So the tangent of 28 degrees, okay, will equal A over 15. So multiply by 15 on both sides, and we get A equals 15 times the tangent of 28 degrees. Now, since 28 is not one of our special angles, let's go to the calculator and we'll type this in. Now, I know I'm in degree mode because I already set that. So I just type 15 times the tangent of 28 degrees. And we get 7.97, so about 8. So A is approximately 8.0. Now to find side C, okay, that is the hypotenuse, and we know the adjacent side. So the two that use adjacent and hypotenuse would be the cosine. So the cosine of theta is adjacent over hypotenuse. And then the secant would be the hypotenuse over the adjacent. Okay, and since we know the adjacent, let's use the secant to solve for this. So we have secant of 28 degrees equals C over 15. So to find C, we're going to multiply by 15 on both sides and get C equals 15 times the secant of 28. All right, so to find secant of 28, let's go back to our calculator, and secant is the opposite or the inverse of cosine, or the reciprocal of cosine. So we're going to do cosine 28, and then press the reciprocal button, and then multiply by 15. And we get about 17. So C is approximately 17.0. All right, now when we get into word problems with these types of situations, we need a couple of vocabulary words here. Angle of elevation, okay, and angle of depression. So the angle of elevation is if you're standing on the ground here and you're looking up, okay, at a point up here, okay, that would be your angle of elevation to that point. Okay, whereas if you're standing up here, okay, and you're looking down, okay, then this is your angle of depression. Okay, so angle of depression, okay, looks down from a horizontal. Okay, angle of elevation looks up from a horizontal. Now, one thing that we want to notice is that these two lines are parallel, which means that these two angles are the same. Okay, so an angle of depression and an angle of elevation should have the same degree measure. Okay, so we have the same measure for an angle of depression and an angle of elevation. So let's look at an example of using that. Okay, if I've got a parasailer attached to a boat with a rope 300 feet long, okay, the angle of elevation from the boat to the parasailer is 48 degrees. Estimate the parasailer's height above the boat. All right, so if our boat is here, okay, and our parasailer, okay, is up here, okay, we have an angle of elevation of 48 degrees. And the rope we know is 300 feet long. And we're looking for the height above the water. Okay, so that is this. So there's a picture of what we're working with. Okay, now how we're going to find that height is, this of course is the hypotenuse. This right here, the other side that makes up the angle, is the adjacent side, which leaves h to be the opposite. So we're looking for the opposite. We know the hypotenuse, so the two trig ratios that use that would be the sine, right? Because the definition of sine of theta is opposite over hypotenuse. And then cosecant would be the reciprocal, hypotenuse over opposite. Since we know the hypotenuse, right, and that's in the denominator of sine, that's what we're going to use. So let's set up our equation. Sine of 48 degrees, okay, equal to the opposite, which is h, okay, divided by the hypotenuse, which is 300. So multiply both sides of the equation by 300, and we get h equals 300 times the sine of 48. So I can just type that right in my calculator. 300 times sine 48, and we get about 223 feet. All right, so that's how we can use our trig ratios to help us find missing sides, just by setting up equations, using the definitions of our trig ratios, and based on the side that we know of our triangle and the side that we don't, that we're looking for, and then we can solve it pretty simply. All right, that's it for part 2. We'll see you back here for part 3.